Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, question 5 in that 2020 paper that we're doing. X squared minus 3x minus 4 equals 0. So now if I go to the log tables, there's a little algebra page on that. Here, page 20, okay? So the first one there is a quadratic equation. Ax squared plus bx plus c equals to 0. So let me just write that. Ax squared plus bx plus c equal to 0. So that's your first task, to recognize that that's a quadratic. You have the x squared, the x, and the number, okay? There's two ways we can solve quadratic. We can use the minus b formula that's given here, or sometimes factorizing works. So let me try the minus b formula first. So I'm literally taking this down from the log tables. Okay, x is equal to minus b plus or minus square root of b squared minus 4ac all over 2a. Okay, so the first thing is, what is a, what is b, what is c? Well, a is the number that sits in front of x squared. So when you've no number there, you can say that a is 1, because that's 1x squared. It's not 0, because if it was 0x squared, then we'd have no x squareds in the question. So a is 1. The coefficient in front of that is I have 1x squared. B then is the number in front of x. So in this case, minus 3. And c is the number on its own, minus 4. Now you can see I'm taking the signs with all of the letters. Coefficients, these are called the numbers in front of the letters, okay? So take the signs with them. That's a minus 3, that's a minus 4, okay? I know the general form of the equation has all pluses in it, but that's just because it's a general form, but it really can be pluses or minuses. So what you'll notice then, that there isn't an x to be seen here in the coefficients. It is literally just the numbers in front of the letters, and we just use the letters to tell us which is A, which is B, and which is C. So when you sub into the minus B formula, you have no x's at all in it, okay? It's just numbers. So minus B then on the outside, you'll know on the outside this one will always change sign because it's a minus. So minus minus 3 plus or minus the square root of B squared, so minus 3 again, minus 4ac. Okay, so I don't even look up here now. I'm literally just looking here, and I can just do it fast because I've done it so often, but I'm filling in the letters that I've given there, and it's all over. And when I say all over, you see I go all the way back to the minus b, all over 2a. Okay, so then x is equal to minus 3 is plus 3, plus or minus. Right, I grab my calculator, I hit the square root sign, and everything there goes in exactly as I have it written. Very important that minus numbers goes inside brackets when you're squaring them, because that is the only way the minus sign also gets squared. So minus 3 squared minus 4ac. So I got 5 for that. All over 2 ones are 2. Okay, there's always two solutions to a quadratic. See that squared there? The solutions to any equation is always the highest power inside in the equation. So this is an x squared, so it has two solutions. If I was solving an x cubed, so a cubic equation, it would have 3 values for x, okay? So it's the highest power. So where did the two solutions come out of? Well, they come out of us splitting up the plus and the minus. So therefore x is equal to, I take the plus in the first one. Okay, so you can see they're the exact same as each other. I've just dropped the minus, and then my other answer comes from 3 minus 5 over 2. So I take the plus sign in my first answer, I take the minus sign in my second answer. Hit the fraction button first, and then 3 plus 5 all over 2. So 3 and 5 is 8 over 2, so x is equal to 4. And 3 minus 5 is minus 2 over 2, is -1. So they are your two solutions for that quadratic. Okay? Now, there is another way of doing it, and it's using factorizing. Okay, so if this question, this was a solve, so you can use the -b formula or factorizing, okay? But if this said factorize out there, you could only use it by this second method, okay? So that's why I want to just do it this way, just for practice. So this is often referred to as guide numbers. So -4, so basically what we do is we set up two sets of brackets, okay? The factors of x squared goes into the left of both sets of brackets. The factors of -4 goes into the right-hand side of each of the brackets. Okay, now there may be multiple sets of factors for each of these numbers. So how do you know it's the right set for this particular equation? Well, you use the middle number to determine that. Okay, so the factors of x squared is really straightforward. It's x and x, so that's easy enough. Now the factors of -4. So that's an even number, so there's generally quite a few options for factors. So the factors of 4, first of all, is 4 and 1. 4 ones are 4. Now it's a minus sign, so 1 has to be a minus and 1 has to be a plus. Or of course the 4 could have been the plus and the 1 could have been the minus. Okay, and then the factors of 4, I have 2 and 2. 1 has to be plus, 1 has to be minus. And there's no real point writing down -2 and +2 there because it's the same thing. Okay, so they are all the different options I could use to factorize -4. Now, which is the right one for this particular equation? Well, which line adds together to give me -3? So if I look down here, +2 -2 is 0, it's not that one. +4 - 1 is +3, so it's not that one, but -4 + 1 is the correct one. So that's the one I take. So then you put the -4 into one bracket and the +4 into the other bracket. Okay, then what you do is you split the brackets, so x -4, and you let each bracket equal 0. And then bring it over so that x becomes 4, bring it over, x becomes -1. And there again are your two solutions, and of course they match the ones we got in part A. So either or, whichever is your preference, okay? But it is important too that you can, I know when I was doing my Leaving Cert, my preference was the -b formula, and I used that most of the time. The only time I would have done it like this was when I was asked to factorize. So what's the difference between a factorized question and a solve? Well, a factorized question wouldn't have the equals to 0 here. It would just be that, and you'd be done with just this line here. Okay, so that's a factorized question. Okay, part B then was functions by the looks of things. Complete the table below to show the value of the function f of x equals -x squared minus x plus 6 for each of the given values of x. Okay, let's have a look at this one, okay? So in many cases, we develop a table as such. We would put our x values down here, -4, -3, -2, -1, 0, 1, and 2. Okay, my function goes in the middle. So -x squared minus x plus 6. And then my f of x, which is the same as y, goes out here. Okay, and what you do is these x values you write down here, you sub them in. Okay, so that this one here becomes minus. So instead of x, I put in the -4 that's over here, squared minus -4 plus 6. Okay, you put that into your calculator and the answer goes here. So let me do this first one. 4 squared minus bracket minus 4. Lots of minuses, loads of room for error in this one. So minus 6 is what I'm getting for that one. Okay, and then I come to my next line. And instead of, so now x takes on the value that's on this particular line. So it's minus 3 that gets subbed in for x in this line. Okay, and on your calculators, you don't need to hit delete. You can just go back to the 2 sets of brackets you've set up, delete the 4s and put in the 3s. Okay, and again, okay, minus 1 squared minus 1 plus 6 minus 0 squared minus 0 plus 6 and minus 1 squared minus 1 plus 6 and then minus 2 squared minus 2 plus 6. Okay, and work out all their answers. Is there a shorter way of doing it? Yes, there is. Okay, and it's using the functions inbuilt into your calculator is a functions function. Okay, so I'm hitting mode setup. So I'm going to put the results here. So I'm on the Casio FX83 GT or one similar. So mode setup button. So top right. And I'm going to option 3, a table. Okay, similar to a table of results that's here. Okay, so hit 3 table. And you can see an f of x flashing symbol, okay? So into that, I'm going to put my function, which is up here. So hit the minus, okay? Hit the minus button. Now, we need to get an x into it so that the calculator knows where to sub in. So I call it the red x, okay? And it's behind the close bracket. So you'll have to hit alpha close bracket to get red x. Okay, and then hit squared, just the x squared button, and you'll see the squared popping in, minus red x again, plus 6, and hit equals to. Okay, so minus x squared minus red x plus 6 and then hit equals. Okay, and that equals logs it into the calculator. Then you get start question mark and it's going, what do you want me to start subbing in for x? What value do you want me to start at? Well, it's here. It's the first value in what's called your domain. So it's minus 4. So hit minus 4 equals, and again equals logs it in. It goes, well, what value would you like me to end at? And we'd like it to end at 2 when we're building our table. So hit 2 equals. And what would you like me to go up in steps of? Well, I'd like it to go up in steps of 1. Okay. And then you'll see you get a table of results. That's your x values here and your f of x values here. And we'll see the first 2 I have there in my table is minus 6 and 0. So I always manually work out 1. Okay, for the purpose of an exam, I wouldn't write in any more than that because it takes too long. So this is how I would present my answer to an examiner. So just 1 to show them I know what I'm doing. Okay, and then I would take the results from the calculator. And your examiners know that this function is there and they're expecting you to do it. So, you know, absolutely don't get penalized for doing it on the calculator. Okay, try and take no notice of the, I suppose, the most left column, because that's literally just counting up from 1. It's like row 1, row 2, row 3, but it means nothing. So you're only looking at the x column on your calculator and the f of x column. Okay, and then these are what we call the couples. These are what we plot. Okay, so up to you whether you write down your couples. So minus 3, 0. So I'm getting them from here. Minus 2, 4 will be my next one. Minus 1, 6, 0, 6, 1, 4, and 2, 0. Okay, so your couples, x before y in the alphabet, x before y when you're plotting. Okay, so what does that mean? Well, that's my x axis here. This is my y axis. So these are all x comma y, and you'd know that from coordinate geometry when we're plotting. So which means I have to go over to -4 on my x axis first before I come down to the -6. Okay, so that is the point -4, -6. I then have -3, 0. I have -2, 4. I have -1, 6. I have 0, 6. And when you have two values like that at the same thing, note that your graph, especially if it's quadratic, is going to go up and come down between those 2 points. So it's not a flat top, it's up and around. Okay. My next point is 1, 4. And then 2, and then back down to 0. Okay. So I forgot to fill in the values here. So where am I? -4, sorry, I'm filling in my x values. So 6, 0, 4, 6, 6, 4, 0. Okay, and then we draw this as smooth as you can. You join the pots together. Okay. Okay, and that is the graph f of x. So try and label all your curves. So draw the graphs. This was the domain that I was talking about. So the domain is the x values that you plot between. Okay, also called the inputs to a function. So we are plotting, sorry, between -4 and 2. Okay, where x is an element of R on the diagram below. So I hope that's okay. I hope that makes sense. Part 3 then said, on the same diagram as the function f, draw the graph of the function g of x equal to f of x minus 2 in the domain -2 to 4. Okay, so this is a translation of a curve of a graph. Okay, there's a few ways of doing it. Okay, I'm going to show you a longer, easier way to figure it out. Okay, so again, I am taking my x values here, and yeah, let me see if I can figure this out now. So I'm going to take my f values here, so -x² minus x plus 6, and my y values. Okay, so I want to subtract 2 of all my x values. Okay. Yeah, okay. So I just want to subtract 2 of all my x values. So let me just copy this. If it'll copy for me with the values in it. Okay. It's probably the easier way of doing it. So let me just. Okay, so I want to develop what is these x minus 2 values. Okay, so what you're doing basically is you're moving your graph over by 2. Okay, and that's why the domain has shifted a bit. So if you see here with the x values, we are going from -4 to 2. Here we're going -2 to 4. So the whole graph has shifted to the right by 2. Okay, so what's going to happen is that this graph is going to shift to the right by 2. Okay, so that these are all going to shift by 2. So I'm doing it graphically first. That's the one that's wrong. As such. So what I've done is I've taken each of the points and I've moved them to the right. Okay, so that's the translation that takes place when you do f of x minus 2. Okay, and then you join them together. As such. Okay, so we just did this one where we plotted the translation. The other way of doing it is if I take down my f of x function, it's equal to minus x squared minus x plus 6. Okay, so that was the original one that I plotted. Now g of x is equal to f of x minus 2, okay? So as you can see, they didn't give me a formula for f of x minus 2, so I need to develop one, okay? And then this will be called g of x. So how do I do that? Well, anywhere there was x in my original function, I'm now going to replace it with x minus 2, okay? So this x here gets replaced with x minus 2 in my new function, okay? And then this x here gets replaced again with x minus 2. And you can see I'm putting the replacements in brackets, and it's because of all these minus signs popping around the place. I want to make sure my signs are right, okay? So that is the expression you need to plot f of x minus 2. So I can develop a table just like I had here for f of x, okay? So let me delete out that little bit. Let's draw a table. Okay, so like such. And my x values that they want you to go between this time is minus 2, minus 1, 0, 1, 2, 3, and 4. Okay, so let's just make our table a bit bigger. And this one is g of x. It's g of x, which is the same thing as f of x minus 2. Okay, let's draw some more lines. Okay, so into my calculator, using that tables function, I am so put the calculator into functions mode, so mode shift 3, and put this into your calculator, okay? So minus, and then bracket x, bracket red x minus 2. So do this one with me, close your bracket, squared, okay? So now I need another minus, bracket, red x minus 2 again, close your bracket, and then a plus 6. Hit equals. We don't want to start at minus 4. This time you see it remembers the result from the last one we put in. So put minus 2 this time, because that's what we're starting with, equals. Put in your end, which is 4, equals, and let's go up in steps of 1 equals. Okay, and let's take down your results. So I am getting at minus 2, I am getting minus 6. At minus 1, I am getting 0. I'm getting 4. I am getting 6. 6 again, 4, and 0. Okay, so that is you then plotting -2, -6, -1, 0, 0, 4, 1, 6, 2, 6, 3, 4, and 4, 0. Okay, so there's your couples, x, comma, y. So let's go back over to our graph. And now we're looking at the purple one. Okay, so you can see now you have -2, -6. Okay. I have -1, 0 as my next one. I have 0 up to 4 as my third one, and so on and so forth. So what you'll notice, depending on how you were taught this chapter, you can either develop a full expression for f of x -2, develop your table and plot it, or when it's x -2, it shifts the graph 2 places to the right. If it was an x +2, so for example, if I was asked to plot that, what it would do is shift this original blue line 2 places to the left. So it's kind of the opposite way to what you would think. Okay, so that is the longer way for plotting that particular function.
If you are interested in technology or engineering, but are not doing higher level maths, why not consider our Level 7 in Electronic and Computer Engineering? This is a 3-year programme that looks at the design and development of embedded electronic systems. These are the medical devices that keeps us healthy, the consumer devices that keeps us entertained, or the controlled systems that keeps us safe on the road. You can then progress on to the Level 8 in Electronics and Self-Driving Technologies, and from there to the Masters.
Check out the link below for more information.